All right, we're back. We got our last two little algebra review videos here, and we're going to do it in two parts. Even though we're kind of talking about the same thing, I thought we'd just break it up. But we're talking about quadratic functions and then how to graph those quadratic functions. So I'm going to show you a couple different ways you can do it and ways to think about it, but we're going to kind of start with the big picture here. So let's do it. Why is that not showing up? Hold on 1 second. I'm smart. There we go. We can do these things. This is all real life. Never giving you anything edited, kids. This is just Mr. T at his best. All right, so let's see. We're going back. See, I wasn't prepared at all. Okay, so I know we did quadratic formula yesterday, but let's just remind ourselves what quadratic function is. So the simplest one is just y equals x squared, or you might see this more next year, right? You might call these functions more next year in Algebra 2 trig. So f of x is a function, so you could have f of x equals x squared. So you could have anything like any of these. You've seen that before. So we're going to talk about graphing quadratics. And the graph of a quadratic function is a U-shaped curve. It's called a parabola. You've heard of it. So, it looks like that, or it looks like that. Here are some examples. So this is just a super simple. This one over here on the left is y equals x squared. Okay, so that's just as simple as it gets. And you can see you have some other ones here. We got one that's opening down. We got wider ones, steeper ones. And we'll talk more about why all of that is. So a parabola, what's really nice about it is it's symmetrical, okay? So two sides match up perfectly. That makes it easier for graphing and other kinds of things you might want to figure out. So the line that divides the parabola into two matching halves is called the axis of symmetry. So we will talk about that. The axis of symmetry divides it nice and evenly. And then the vertex is the highest or lowest point. Okay, it's where those two matching halves meet. They meet at the vertex. If it's a parabola that's opening down, your vertex is going to be the maximum, is going to be the highest point. Your vertex opens up, you're going to have a minimum there. Okay, and that will be the lowest point. So that is parabolas for you. So remember, when we do this, okay, our equation is y equals ax squared plus bx plus c equals 0. That's our equation. Or sorry, you could have it equal 0 if we're solving it. Or it's just y equals this. Okay, that could be your function. So if the number in front of the x squared is positive, okay, you're gonna have a vertex that opens up, and the vertex is the minimum. Okay. If your a term is negative, it's gonna open down, and your parabola's vertex is gonna be a maximum point. Okay. Let's see. This is old thing I'm reusing, but we're gonna for today, we're gonna take a quadratic function, we're gonna make a table, and then we can graph the value. So that's one way you can graph something, is just make a table and graph those points. That can be really easy. That's kind of what your calculator does. So I got a different example for you. So I'm gonna hold on, change one thing here. I just wanted to show you one before we started. So I put this into Desmos, okay? Now you're looking at two graphs here. The red one right here is y equals 1/2 x squared. So if your a term is smaller, you get a wider parabola. Okay, so let's say we put 1/8. Okay, we put in 1/8 x squared. Look how wide the parabola gets. If we have a higher slope, a steeper slope, it gets steeper, right? So this blue one right in the middle here is just 2x squared. We put in 6x squared, right? It's going to be super steep, okay? But you see that all of these ones are starting at 0, 0 because all we have is y equals x squared and then something in front of the x squared. So that is what controls the width. How wide your parabola is based on the number in front of the x squared. And then again, if you had a negative, so if we did negative 4x squared, okay, that's going to be, also steep, but it's going downwards, okay? And I could change my 1/8 x squared to negative and it'll just flip, or I flip it back, okay? So let's graph one on our own, and we're going to see what happens when we add the c term. Okay, so now we're in here, and we get y equals 2x squared plus 3. Now I said we're going to make a table. Now, usually you want minimum 5 points on a quadratic. I know when you did linear equations, sometimes you just did 3 points. You want 5. You want the vertex, and you want the other ones. Now, I know we're going to get, yeah, we're going to make a table. So, usually a good rule of thumb for these ones, when we don't have the bx term, right? We don't have a b term in here, just have ax squared plus c, is just do -2, -1, 0, 1, 2. And again, these are symmetric, so that will help you with the graphing. I'll show you how in a sec. So this is our x value, okay? What we're plugging in is x, and then our output, that's our input, is the x. Our output is the y, okay? So we input the x, we get the output and the y, we put them together, we get a coordinate point, right? So I'll just show you one. So we do 2 times, plug in your x, -2 squared plus 3. Okay, so you just plug it in. -2 squared is 4. 4 times 2 is 8. Plus 3 is 11. So our first point there is -2, 11. Okay, so this guy's going up quickly. If we plug in -1, -1 squared is 1. So we get 2 plus 3 gives us 5. 0 is going to get rid of this term. So we get 3. So it's 0 and then 3. And now watch this one. So we do 2 times 1 squared again. Well, 1 squared is the same as -1 squared. So we get 5 again. So you see how it's going to be symmetrical? So this one, last one, is going to be 11. And you could double check me, but you're just going to get 2 squared, right? The squared is making everything symmetrical, right? That's why it's symmetrical, is because the squared is turning these negatives we're inputting to the same value as the positives. That's why it's symmetrical, is because of that squared term, okay? So there we go. We got all our points. So now let's come down. We'll make a little graph, huh? Check this guy out. I don't know how often I've graphed on. Why don't we count by twos? Well, yeah, we'll count by twos. Okay, we're counting by twos. I could do a better job of labeling all this, but let's just do a quick dirty graph. So 0, 3, let's change colors. 0, 3 is there. And then we got -1, 2, 4, 2, 2, 4, 6. So it should just be there. Okay, and this one's going to be symmetrical, so it's going to be there. Sorry, I should give more space, huh? And then we got -2 all the way to 11, so 2, 4, 6, 8, 10, right there. And this one will also be Okay, so there you go. There's your parabola. And that's just a little bit of graph in there. Not too bad, right? Not too bad. I think that's going to be it for this first part, and then I'll show you how to graph when we have the B term. So remember, this is the C term, okay? One more thing, and then I'll end it. This is the C term, and what does the C term do? It raises it up or down, okay? So the C term here moves the graph either up or down on the x-axis, okay? The B term is what's going to move us left or right, okay? So up and down C term, width and opening is the A term, and then B term is going to move us left or right. Good work, folks. Nice job out there.